Okay. So how have you done it? We've done, it's going to be 1 plus, and then it's nx, so it's just going to be n is 5, so we've got 1 plus 5x, and then we've got plus n times n minus 1 over 2 factorial times x squared. So that's going to be 5 times 4. So 20 over 2 factorial is just 2 x squared, which obviously that is just 10.
Yep.
Plus, well, it's going to be n times n minus 1 times n minus 2 over 3 factorial x cubed. So that's 5 times 4 times 3, which is 60.
What was the factorial
So
again?
3 factorial is 3 times 2 times 1, which is 6.
So it can be 4.
X cubed, which is 10. And you hopefully will be noticing the pattern. The 1, 5, 10, 10. So the next one is going to be 5. Put it down here and run that space. Plus, well, the next term is going to be n times n minus 1 times n minus 2 times n minus 3 over 4 factorial, which is 120 over 4 times 3 times 2. 24, which is 5. So we end up with 5.
And then just x to the power of 5.
That'd be x to the power of 4 plus.
X to the power of 5.
Okay. We will end up with x to the power. But what happens if we go further? Which is quite, because obviously you know to stop, but this formula is not for stopping, right? So x to the power of 4, we've done the x to the power of 5. Let's go to, this would be n minus 4, n minus 5, all over 6 factorial, x to the power of 6. So you know there's no x to the power of 6, but the formula would allow you to carry on going. But what's going to happen? Okay, so this would be 5 times 4 times 3 times 2 times 1 times 0 all over x to the power of 6. And then obviously the whole thing is just 0. And any term after that,
there's an x minus 5 in it.
Because there's an x minus 5. So you're always going to have a times 0. Therefore, any subsequent term in your infinite series is just going to be 0, 0, 0, 0. So that's why it does work. Obviously, you're not going to use this formula for this expansion, are you? You've got a much quicker, much simpler way to do it. Okay. However, what happens if we want to do something like this? Find the first 4 terms in ascending powers of y. They're just setting the question y between minus 1 and 1, so you know that. So how do we do that expansion?
Is that to the power of 4?
No.
Oh, it's the minus 1.
So we've got to write it in a form that we can deal with it so far, haven't we? Which means this is going to be 1 minus y to the power of negative 1. Because it's a 1 over x is x to the minus 1 thing. Yeah, you're right. So we can put it in that form. Now we've got it in the binomial raised to a power. We don't have a positive power, so we wouldn't be able to use our previous one. Okay, go, yeah. So let's have a look how it goes. So what's the formula? It's going to be 1 plus nx is minus 1x, we'll tidy it up afterwards, plus so minus 1 times minus 1 minus 1, which is minus 2 over doing question mark instead. I want a 2 and I want an exclamation mark. X squared. The next term is going to be -1 times -2 times -3 over 3 factorial x cubed, and we
So
just want
far.
one more at -1 -2 -3 -4 4 factorial x power 4. Why would this one carry on forever? There's nothing turning 0 because we've got a negative power. We're always going to have -4 -5 so this would be an infinite series. So we're never going to do a complete expansion of this.
That's why it only asks you for the first 4.
Exactly. Yeah, you're never going to be asked for a complete. You can't do a complete expansion. But also, we'll come back to the where and when it's valid. Okay, but let's do this. Let's simplify. What do we end up with then? So we've got 1 minus x
2 over 2.
plus 2 over 2. So just x squared. It's going to be a minus 6 over 6. So just minus x cubed
Plus x to the power 4.
plus x to the power 4.
Does it just keep going then? Is it just
Oh, because it is the factorial. So
plus
Yeah.
5 plus x to the power 5 x to the power 6?
Yeah, so you just keep going, wouldn't you, in that way? All right. So we've managed to do an expansion, but we've only done the first 4 terms of the expansion. That's all we're asked to do. All right, bit of practice. Let's look at this next question then. Find the first 3 terms of that. I'll let you do that one for yourself. I didn't expect the question to come so soon. I thought you'd mess it up. So what do we do? First of all, we have to rewrite that as 4 plus y to the power of a half. Okay. So we could try expanding that, but there is an issue, which is this is not in the form 1 plus x to the power of
Do we have to
n.
take out a factor of 4?
So you have to take out a factor of 4.
And then is it y over 4 then?
Yes.
Yeah.
So let me just ask you this. So this is an important bit. What would it become then?
What?
1 plus y over 4.
Did 4 and then
Everything else.
So 4 brackets
1
Everything.
plus y.
1 plus y over 4
Alright.
to the power of a half. No. Very close, but it's not quite right. What are we missing? So we're not actually taking out a factor of 4. We're going to take out a factor of
Root 4.
2, yeah. We're actually going to take out a factor of 4 to the power of a half. Okay? You've got to apply the exponent. You can't just take the 4 out of the brackets and pretend it wasn't raised to the power of a half before. So we're taking out a factor of 4 to the power of a half, which is actually just 2. Okay? So now what you're going to do is do that expansion and multiply it all by 2
At the end.
at the end. But you're only going to do the first 3 terms.
Generally, we were never taught these rules of
Okay?
Not even close. So could you go through that?
You want me to go through it? Okay. So, what we'll start with is it's 2, I'm going to put that on the outside, and then I'm going to go through. So, we can consider this as 2, 1 plus, no, actually, no, I'm not going to do that. So what's the formula? It's going to start with 1 plus. Okay? Then it's nx. The next bit is nx. So n being a half
oh, that's fine.
times x is y over 4. plus a half times a half minus 1 is minus a half. Okay. Over 2. Sorry, not x. It's x squared would be y over 4
Yeah, I know where I went
squared.
wrong.
But we don't have to go any further than that.
Okay.
Yeah, you see mistakes, everyone. Yeah. All right. The next question, I guess, is pretty important, which is, what values of y is this expansion valid for?
Can you scroll up to the answers?
Now, does that make sense what I'm talking about? Why would it or would it not be valid?
0. Square root of 0.
Potentially, but the square root of 0 is 0. That's fine.
What negative numbers?
Negative numbers wouldn't be, yeah, that would be an issue.
What, so if it's
Definitely.
just less than -4?
But I'm going to take you back to the first notes page that I showed you, which is, I know we didn't talk through. Where have we met infinite series things before?
Yeah.
Sequences, yeah. When can we add up an infinite
When it's a
number of
fraction.
numbers? So when the what's a fraction?
When the numerator is
Yeah, but what is it?
or
What is the numerator? That is, the numerator is not just a numerator.
less
What
than
is it?
1. Less than 1 but greater than -1.
Yeah, but it's the ratio. That's what I'm looking for, right? Why can we add up an infinite number if the ratio is less than 1? It's a fraction. It's what's happening.
It's never becoming
Converting.
1. Yeah.
Why is it converging?
Because it's getting smaller and smaller.
Because each number is getting smaller as well. If you take the previous number and multiply it by a fraction, the next number is
Smaller.
smaller. All right? And it gets smaller and smaller. Does it matter if it's positive or negative?
No.
No, because if it's a negative ratio, you just alternate between positive and negative, but you still get a smaller and smaller fraction when taking the absolute value. So, is this the same as a series, adding up a series? What is the ratio of going from each one term to the next term?
And minus something.
Not really, actually, because these are just constants. This is a constant, the 1 is a constant. All right, so remember with the sequence, it's like the ratio. So this is just a constant, this is a constant, this is a constant,
That's cool.
right? Where's the ratio? What's the thing that's multiplying every time? So the main difference here to here is that we multiply by x. What do we do to go from this one to this one? We multiply by
X.
x again. What do we do from this one to this one? We multiply by x. So what's the ratio?
X.
X. Therefore, this value x gives you the ratio when you consider it as a geometric sequence, geometric progression. So we know that the x value has to be between -1 and 1.
Yeah.
Otherwise, it will just get bigger and bigger and bigger. All right. So when we look at this, we're saying that the absolute value has got to be less than 1. So when we expand something like 1 plus 3x to power of n, then it's the 3x bit here. It's the 3x that must be less than 1 because it's the 3x that gets multiplied every time. Yeah, that's the ratio. All right. Otherwise, it's not going to converge. If it doesn't converge, the expansion is not valid. It's just going to go on forever and ever and ever. You know. So what we're saying is, and we've already done this bit, the the 1 plus ax. You've already looked. So what we're saying is that we have been able to apply this formula to this expansion. All right, not a problem. How long would this expansion be if we wanted it to be? An infinite. I did the problem here. These should all be y's, shouldn't they? This should
Yeah,
be
that's what- yeah.
1 minus y plus y squared minus y cubed plus y. Sorry, I meant someone said it was x, and then I said no y, and then wrote x myself. This expansion, if y is the wrong number, will just go on forever, and we'll never get an answer to it. All right. So y has to be a value between -1 and 1 for it to be valid. And they told you that in the question, so that's all good. All right. Because what's going to happen? Y to the power of 4 is going to be bigger or smaller than y to the power of 3? Smaller, because y is a fraction. So each term is going to get smaller and smaller and smaller. So what about this one then? Now. So what have we now decided? Not that
root,
y,
but root.
not root y. This is not what we expanded. We expanded this. Okay. Therefore, what values of y is this valid for? Well, we're going to say that y divided by 4 must be less than 1. Got lots of i's drifting off in different places.
Would it be less than 0?
No, we're saying it's got to be less than 1, just like all those. Yeah, remember we said 1 plus x to the power of n, x has to be less than 1. If it was 1 plus ax to the power of n, we're saying ax must be less than 1. So by converting, we had 4 plus y to the power of n. Doesn't matter that it was a square root, therefore negative or to a half.
So y over 4.
We're
is
actually
less
going to have, it's 2, 1 plus y over 4. So we're actually only dealing with this bit with the expansion, aren't we? That's the bit we have to consider. So which bit has to be?
y over 4.
Y over 4 has to be less than 1. So what can y be?
Less than 4.
So y can be less than 4.
But greater
Now-
than -4.
Well, that's why I put the absolute values.
Oh, okay.
So you could write that like this. It'd be
Is
like-
that what absolute values means?
Yeah.
Positive or negative?
Yeah.
Okay.
It's the distance from 0, isn't it? So if we consider that, does that make sense the way Abdul was talking about it before, which is, well, it's a square root. What values of y am I allowed to put in?
Positive.
Well, what's the first value of y that I can put in? Well, I can put in 4. Is putting 4 in okay?
Yeah.
Yeah?
So minus.
Is putting -4 in okay?
Yeah.
Yeah? All right. But anything
Must
where
be
y is less than -4 is going to be a problem.
Yeah.
Yeah? All right. Okay. So we've basically covered a few things. Let me just summarize before I let you get on. You have a formula. Your formula is in your formula booklet. Right? You
What
don't
is
need
it?
to remember it, but it's not hard to remember. Okay? It will converge if your x is less than 1 or greater than -1. If you're expanding something ax, then the validity is that whole thing, not just the x. Okay. This will only work when you've got a 1 plus something. So your focus should be on this. You must be able to rewrite it in the form 1 plus to do it. And then we go through. And if we can use it in the old way that we did before, just with a positive, we've shown that we just get 0, 0. So it will terminate, even though it's an infinite series. But when we start applying it to negative exponents or fractional exponents, it will carry on forever. It's only valid for certain values. But if it goes on forever, Massey, what will the question be?
What's the infinite
On the
series?
first 4 terms.
Find the first 4 terms, find the first 3 terms. You will never be asked to find a complete expansion. It won't.
Fraction 1, if it's larger than 1, will not convert. Like, if you have 1 minus y to be like 1.5,
So remember,
that would just go
these,
on
the
forever.
fractions just become the coefficients.
Mhm.
It's this value here that matters, isn't it?
Oh,
That's the ratio. This fraction, this exponent, is only part of the coefficients, and that's not what the problem was. It's this ratio that gets multiplied every time. So if this ratio is bigger than 1, then that will make an infinite series that we can't add up. All right. So it's the ratio bit that matters, not the exponent. The exponent doesn't matter. It just so happens that when your exponent is not a positive integer, you won't have a terminating series. You'll have an infinite series. So it only works for certain values.
Yep.
Okay. All right. Over to you then. I only did a couple. I think that's covered most things, but you can. There's a couple bit more for you to read. If you look at page 108, from page 108, you can.
Can I borrow this?
Yeah, go for it.